So in this lesson, we're going to be talking about how we partition a line. Partition is a fancy word for basically to separate or to divide. So how are we separating this line into a given ratio? The easiest way to me explain this is to just do one instead of going through the steps. So the first thing that we're going to do is first plot our endpoint. So we're starting at A, so -6, -3. And then going to B, which is 9, 7. So this is my original line. So now we're supposing that point Q was on the line such that AQ to QB is 3 to 2. Find point Q on the line segment and label it. What this is basically saying, right? If we imagine a number line, right? We're saying that at some point, right, from QA to B, that you could split this piece up into 3 pieces, and this piece would be 2 of the same length. So altogether, we're splitting this line up into 5 different pieces. 1, 2, 3, 4, right? 1, 2, 3, 4, 5, and saying that we want to find the point that splits us into 2 groups, one of 3 and one of 2, right? So we're actually looking for the point that is 3/5 of the distance from A to B. So what I'm going to start with is I'm going to highlight my run and my rise to get from A to B. So if I look here, from A to B, so it's from -6 to 9, this is a run of 15, right? The entire thing is 15. The rise from -3 to 7 is a rise of 10. Now, I want these distances, right? I want 3/5 of that distance. So I'm going to take my run and multiply it by this fraction. And you'll get 9. So now, instead of going the entire 15, you're going to go over only 9 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is where we're going to stop when we're finding Q. And now we do the same thing with the rise. 3/5 of your original rise, which gives us 6. So now, instead of going up 10, we're only going to go up 6. 1, 2, 3, 4, 5, 6. So now I have my point Q. Q is at 3, 3, right? And that's how we find that's how we partition a line based off of the given ratio. So now we're going to do the same thing. So what are the coordinates of the point Q on the directed line segment from, so we're going from 3, 5, this is M, to N, 8, -5. Such that MQ to QN is 2 to 3. So this is very similar because, again, we're going to be splitting it into a total of 5 distinct boxes, but here my fraction is going to be 2/5 because I care about the point that is 2 fifths of the distance. So again, I'm going to highlight the run and the rise. I went too far. So I'm doing highlighting the run and the rise. So the run here, it's 1, 2, 3, 4, is 5 boxes, and the run is 10. So I take my original distances and I'm multiplying it by this fraction. So my new run will be 2, and my new rise will be 4. Technically negative 4 because we're going down, but just to keep it simple. So if I was going to mark that, I'm going to go over 2 and down 4. For my new point Q, where Q is 5, 1. So it's important that you're making sure that you're starting at the correct point. You're going from M to N so that your point that you're creating is not on the wrong side. What are the coordinates of point Z on the directed segment from K? So we're starting at K, which is -5, -4, and L, which is 5, 1, such that KZ to ZL is 3 to 2. So again, there is a total of 5 pieces that we're breaking this into, and I want 3/5 of my original distances. So if I highlight my rise and my run, so this is my rise, and this is my run. So my rise is going to be 5, and my run is going to be 10. And now we do the same thing. We're multiplying my fraction by each of these to get my new rise and run. So my new run is going to be 6, and my new rise is going to be 3. So I'm going to go from K, I'm going to go over 6 and up 3 to get Q. Q is at 0, -2. Oh wait, hold on. I think I didn't go over far enough. I'm going over 6. So 1, 2, 3, 4, 5, 6, and then up 1, 2, 3. Sorry about that. So Q is actually at 1, -1. So again, what are the points of A that would divide the segment with endpoints P and Q into a ratio of 4 to 1? So we're starting at P, which is 2, 8, and Q, which is 7, 3. Draw your segment. Highlight your rise and your run. So this is the rise. This is my run. My rise here is 5. My run is also 5. So both the distances are going to change the same way. The fraction, so again, you imagine this is your whole line. You want the point where there's going to be 1 on one side and 4 on the other. So you want a total of 5 boxes that you're creating. So we're doing out of 5, we want where it's the 4th out of the 5th times your rise and your run. So it's going to be 4 in both cases. So I go back to my starting, and I'm going to go down 4, over 4. And this is point A. So A is at 6, 4. It now asks to prove that PA to AQ is equal to 4 to 1. So you have to find the distances. So PA, so the distance, so P was at 2, 8. A we found at 6, 4. And Q is at 7, 3. So PA, so doing the X's, then the Y's. So that's going to be 16 plus another 16, which is the square root of 32. And then AQ, 6 minus 7 squared plus 4 minus 3 squared. So that's going to be 1 plus 1, which is the square root of 2. And so now if I do the square root of 32 over 2, I should get 4, which I do. So that tells me that this simplifies to a ratio of 4 to 1, so the distances are actually in a ratio of 4 to 1. So for homework, there's 2 questions. So what are the coordinates of the point on the directed line segment? So we're starting at M, which is -5, -4, and L, which is 5, 1. That partitions the segment into a ratio of 3 to 2. So again, we have that break where we're going into a total of 5. So we're doing 3/5 of your rise and your run. Run and rise. Five and 10. Six and 3. So now I'm going to go over 6 and up 3 to get the new point of 1, -1. So here, so we're starting at 6, 5 to 4, 0. Point P is on segment AB, so we want, again, 2 to 3, so that's going to be a 2 over 5 for both the rise and the run. So we have 2, 1, 2, 3, 4, and 5. So here, we're going to start from A, and we're going to go down 4/5, so almost 1. I'm sorry, we're going to go over 4/5 and then down 2 for point P. So point P is what happens when you go to the left from A. So A was at 6, so it's 6 minus 4/5 over 5 with Y, 5 minus 2. So it's P, which is, let's see, so it's going to be 5 and 1/5, 3. And that's how we partition a line. Just gotta have to practice the steps and make sure that you're setting up the fraction correctly. In this case, all the fractions had a denominator of 5, but if you were given a ratio, for example, of 3 to 4, you would be looking for a fraction of 3 over 7, because 3 plus 4 is 7. Just something to keep note. All the examples had 5. Probably something I'll change in the future, but just something to be aware of.